So let's talk about converting fractions into decimals and vice versa. So let's say that we had 3 1/5, and we wanted to convert that into a decimal. So there are a couple ways that we could do that, but what I would suggest is we know that there's going to be 3 point something because this 1/5 is going to be turned into a decimal. So we need to figure out what that 1/5 is as a decimal. And you always divide the denominator into the numerator to figure out what that decimal is. So we'll do 5 into 1. Put this decimal point there. 5 goes into 1 0 times. Bring down the 0. 5 goes into 10 twice. 2 times 5 is 10. And then we terminate. So 0.2 is the equivalent of 1/5. So 3 1/5 is the equivalent of 3.2. So that's how you would convert that. Let's try another one. Let's say that we had 3 7/9. So again, we know that 3 is going to start, but then we're going to have a decimal, and we need to figure out what 7/9 is. So 9 goes into 7. We'll put our decimal point here and here. And let's put a couple of these. So 9 goes into 7 0 times. So that's 7, drop the 0, 70. 9 goes into 70. Well, 9 times 8 is 72, which is a little bit too big. So why don't we do 7? 9 times 7 is 63. So that leaves 7 down here. Let's drop another 0 down. 9 goes into 70 again 7 times. I think I see a pattern. While this is never going to end, meaning it's never going to terminate, it is going to repeat forever. So 9 goes into 77. So it looks like it just goes on. We use these 3 dots and ellipses to show that it goes on forever. And since we have these 7s, it shows that this pattern of 7s goes on forever. So there's a couple ways that we could show that. We could show it with this ellipses, which is great, or you could show it with a decimal bar. So another way to show that it goes on forever is to put a bar over what is repeating. So in this case, 7 is repeating forever, so we just need 1 7 and that bar over that 7 to show that it goes on forever. So since 7/9 is 0.7 repeating forever, 3 7/9 is going to be 3.7 repeating forever, so we'll put a bar over that. Again, the other way, we could use an ellipses. So the other way to show that, which is perfectly fine, is 3.7 ... Okay? Or if you want to, when you're using a couple dots, it's fine to put maybe 1 or 2 or 3 7s in just to show that it really, but any of those ways is totally fine. Now, sometimes what's going to be repeating is a pattern that's not just one number over and over and over again. So if we wanted to show, let's say, 3.856, 856, and 856, and it just goes on like that forever, we could use our ellipses, our 3 little dots, periods at the end. So we could do that. You could shorten it up, so you could say 3.856, and you wouldn't need to do all of these. Just one round of that cycle is fine, and then you could put your ellipses. Or what you could do is 3.856, that's a full cycle of a pattern, and you'll put the bar over all of that. Do you see that? So this is a great way to do it using the decimal bar, or you could use the ellipses. They mean the same thing. I also want to point out that sometimes the numbers on the right side of the decimal point, sometimes it doesn't just go right into that pattern right away. let me show you an example. Let's say that we had 3.7855555, and that goes on forever. Do you see that the 7, I want to show that the 7, 8 doesn't repeat. It's the 5s that repeat forever. So in order for us to really show that very specifically, we'll be able to put it in this form. 3.78, the 7, 8 is not repeating, so we're not going to put a bar above that, but we will put a bar above the 5. So this would be the best way to represent what's really going on here, that this is going to be 5s forever, but the 7, 8, it is a repeating decimal, but it turns out the first 2 numbers here are not going to be repeating. So that's why we put the bar just over the 5. If we put a bar over the 8, 5, if we had a bar over the 8, 5, that would be explaining that it would look like this, 3.7858585. Do you see? So that would be representing another number where 8, 5 is being repeated, but the 7 is not. So this bar, this decimal bar, is actually or repetition, you could call it a repetition bar, repeating decimal bar. It is a very useful thing to have. So I just wanted to go over some of those, and we'll go over more examples in the next video.